Alright, so I got cut off there. The memory on the computer was full. So let's finish this up here. We're almost done. So like I said, if we had the full function, we probably would just find whether they were positive or negative on each interval, and then we would see if it was changing from positive to negative, and that would tell us whether we had a minimum or a maximum or not. But here, so what we're going to do is look at those critical numbers. That would be -1, 0, and 1. And so we're just going to plug those in to show how we can use the second derivative test. So if we plug in -1 to the original there, that would be -3 plus 5. Wait. Up here. -3 Oh, we need to find the second derivative and plug it into the second derivative. Okay, so that's what we need to do first. So the second derivative is going to be 60x cubed minus 30x. Alright, now we're going to plug in the numbers into the second derivative. So that's going to be -60 plus 30. So that's going to be negative. So that's concave down. And that means we have a maximum. So we have a relative max. And that's going to be -1. And if we plug -1 back in there, we're going to get -3 plus 5. So that's going to be 2. So we'll have a relative max right there. Now if we plug in f double prime of 0, we get 0. So that means that the second derivative test fails, which means we have to go back to the first derivative test, which is, we could have just done the first derivative test anyway. But alright, so if we plug 1 in here, we get 60 minus 30, which is positive. And so that means it would be concave up. So that means we have look, right here, it's a minimum. We have a relative minimum, and that's going to be 1. And if we plug 1 in there, that's going to be 3 minus 5, which is -2. Okay. Now it would be worth it to go back and look at this because the second derivative test failed. And so if we go back to the sign chart here, if we plugged in -2 into the derivative would be -2. That would be 16 times 15, and this would be 4, so that would be positive. And then if we plugged in -1/2 here, that would be negative. And if we plug in +1/2, that would be negative also. And then this would be positive. So what we're getting is we do not have a minimum or maximum here because there's no sign change on 0. It's not changing from negative to positive. And you can tell that by the multiplicity. If something has even multiplicity, then it's not going to change. So that's where I kind of mentioned that. But let's finish this up. So here's a case where we have to use the second derivative because we don't know what the actual function is. All we have is the second derivative, and we have the values. Kids miss this all the time, and I don't know why. It makes no sense. Literally, when you see this second derivative test, all you have to do is plug these numbers into this function. That's how we're going to start. So f double prime of -4. Okay. So that's going to be -6 times 16. Negative times a negative, that's going to be plus 24, and then plus 23. So that is going to be negative. So that means it's concave down. The original function is concave down. So that's a maximum. So we have a relative maximum at x equals -4. And that's it for that. And then we're just going to do that for the other two as well. And all the time have problems with this. Right, exactly how we're doing it, do it the same way. So negative 1/2, so that's going to be negative 6. Negative 1/2 squared is going to be 1/4. Negative times negative is positive. Half of 6 is 3, and then plus 23. So that's positive. So it's concave up. That's a minimum. So we have a relative minimum at x equals negative 1/2. And we don't even have the original function, so we can't find out what the minimum is with this information. And we're almost done. Last one, plug in 3. So if you plug in 3, 3 squared is 9, so that's going to be negative 54. And plug in 3 there, that's going to be negative 18. So that's going to be negative. I don't even need the actual number. I just need to know, is it positive or negative? It's negative, so it's concave down, the original function. And so we have a relative maximum. You can see it. That's the highest point at x equals 3. And some people are going to get that wrong, and I cannot explain it because... All right, so it's about that time. Have a good day.